So hi, welcome back to our C++ quick crash course, especially for OpenFOAM users who want to kind of edit this solvers. So as we can see, what we have done in the last video is just addition, and that is barely enough to even understand what this is talking about. So we have to keep moving, all right, to more complicated functions. All right, so let's go. So I've added all this to GitHub already. So what we want to do in the coming video, in the next video, is to talk. This video, we want to talk about more complicated stuff. All right. So we want to move on from addition and multiplication to something a little more complicated. Okay, not complicated. Just we want to move on to other things. So let's try division. Okay. For example, we want to write 1 divided by 2. So 1 divided by 2. That should give us 0.5. So let's do a compile and run g++ of math.c++ with the output of add a and b. Okay, so let's run the add a and b script. Okay, add a and b, 3 and 3 will give you 6, but instead we have the division of 0. Why is the division 0? Why is the dividing 0? Well, the thing is, how this thing works is that if you look at Stack Overflow, you can check a very quick reference. So why is it returning 0? Is because, for example, 1 divided by 2, or in this case 3 divided by 5, that actually gives a number of 0.5. But since both of these numbers are integers, they will just say, oh hey, 1 divided by 2 is 0.5, so we'll just round it down to 0. Or we'll get rid of the 0.5, so to speak. So in that case, if we run a 4 divided by 2 integer, okay, oops, compiled by mistake, vi math.c++, if we do a 4 divided by 2, that should give us a 2. That means the division still works. But it's for integers only. So 4 divided by 2 still gives you 2. And let's do it, let's just give it a test. Let's say we have 9.9 divided by 2. Okay. Or rather 9 divided by 2. That would also give you, that should give you 4. Okay. So yeah, we need to run add a and b. Okay, 3 and 3 give you 6, and 9 divided by 2 give you 4.5, but they get rid of the 0.5 to give you 4. So the workaround for this, of course, instead of giving integers, you have to give a decimal number, or in other words, a float. So if you have a 9.0 divided by 2, all you need to do is this, compile again, and run the code. So 3 and 3, and it gives you 4.5. Alright, so now with this, hopefully we can run a simple calculator for kinetic energy. Kinetic energy is half mv squared, right? So that will encompass both power and division. So that will introduce us to that. So instead of a and b, let's give it m and v. Alright, m and v, because we want to include half mv squared, right? That's kinetic energy. So instead of adding a and b, we're going to calculate ke. Ke equals half mv squared, right? That's a simple physics. So indicate your mass in SI units or kg, and indicate your velocity in meter per second. Okay, so that's what the statements are going to be, and then we want to include m and v. All right, we don't need the last statement anymore. That was demonstration. And then I'm going to have 1 divided by 2 times, half, insert, okay, so half mv v square. So this is how we'll normally write it in MATLAB, right? So let's try that in C++ and see what happens. Okay, so we're going to compile it, and then it's going to give us some error. So what is error? It says the invalid operator of integer and some unresolved thing. So how do you have power in C++? You cannot use this to the power of 2. Now if you look at Stack Overflow, another very common question is this, and oops, how they tell you to add power is to use the power in the CMath library. Okay, to include the CMath library, you need to type this at the top of the file. So include CMath. Alright, so we can't just include string, you have to include CMath. So this is the other library we need to take a look at. Alright, so I'll include these links in the video description just to, like, you know, give credit to those people who are answered. So include CMath into our libraries, save, and instead of v square, we need to have v and 2. Power, v and 2. That's all. Alright. And then we save and quit and see what happens again. So we are, oops, we should not having, we should remove this at A and B. Alright, this is no longer needed. Instead, we should give the output as KE calculator. Alright, so let's run KE calculator. So we'll give you a mass of 10 kilos, 10 kilograms, and 9 meters per second, but it still returns 0. Why? Well, a quick look at our math.c++, vi math.c+, will give us the answer. Remember just now we were talking about dividing integers? We cannot use integers to divide. So we'll need to provide the floats, right? So in that case, we'll just do a bracket, and we have a 1.0 divided by 2.0. This will tell C++ that it's a double and we expect decimals. So this should give us the correct answer, half mv squared. Okay, so let's run, oops, 1. We need to compile again. So let's compile again, G++ of math.c++ with the output of KE calc. Alright, and that's done. So let's run KE calculator, and let's run 10 and 9 meters per second, and you have the kinetic energy of 405. So you double check with the calculator to see whether it's running correctly. 0.5 times 10 times 9 squared. Oops, sorry. 9 squared. Oh, sorry. Okay, never mind. Let me do 9 times 9 times 0.5 times 10. 405. Now we know our C++ code is working correctly. So this is just some of the basic math functions that we need to know. Of course, if you want, we can calculate square root as well. So what is a common physics formula or math formula you're familiar that has a square root? Okay. Well, I can't remember any of those formulas offhand, but let's just for the sake of doing some math, oops, I didn't compile by accident. Vi math.c++, and let's just add additional 2 lines at the bottom. C out. Okay, let's say I want a square root of 2.0. Alright, and end line, and C out. So we want to compare this these 2 lines. So see whether they produce the same results. Square root of 2 and 2 to the power of half. So that's just one example. See whether the square root function actually works. So G++, some K calculator, and run the K calculator. So 10 kilos, 9 again, and we have 4, 5, and then we'll see that square root and power 2 to the power of 0.5, that will give both of them will give the same answer. So these are the standard math functions. Of course, we can do more complicated input outputs. For example, in fluids, the Reynolds number is very important. So yeah, I have one of these. I mean, we can calculate some Reynolds number. Based on this, we can just ask for the velocity u. We can ask for some characteristic length d, viscosity mu, and of course the density rho. After that, we just tell C++, hey, I want to solve rho u d over mu, and then it will just spit out the Reynolds number for you. It's very simple. It's just as simple as that. If you can do multiplication division, we can calculate Reynolds numbers, especially for fluid mechanics. That's basic. So without further ado, I'm going to save this and upload it on GitHub. So, okay, git add, git commit, some more basic math added. Okay, so multiply times divide, or add, subtract times divide. Oh, we haven't done a subtraction yet, but okay, I mean, for the sake of completeness, let me do one subtraction case. Okay, vi math.c++, and then we can see out subtraction case. So inline and see out 2 minus 3.555. Okay, so that should give us a negative number, and we'll save and quit, and we'll compile. Okay, G++, math.c++ with the output of KECalc, along with some other things. KECalc 11. Okay, so we have a subtraction, and then we can see that negative numbers are spotted out. So this is very quick run through. So oops, wrong code. So git add, git commit, plus, minus, times, and divide cases added or demonstrated. Okay. Alright, I forgot. This is the message I need to. Okay, there you go. So git push origin master. Alright, so just uploading this on GitHub, the repository, link you can find in the description. So yeah, that's it for basic functions. So in the next video, I want to talk about something a little bit more complicated, basic math functions. Square root, we have talked about plus, minus, times, divide. We'll talk about some of the things we should be watching out for, like always try and use double or float to do your division cases. Alright, so next thing, probably in the next video, want to talk more about functions. And what are functions? Okay, so I have made a Reynolds calculator, and let's look at this functions.c++. Alright, so what I've done here is to say, hey, I have a Reynolds number calculator, and it does use a rho, u, and d, and divide by mu, so it does calculate some Reynolds number. Okay, and what does it do? Let's do a Reynolds calculator. So velocity 10 meter per second, density 1000, that's water, dynamic viscosity, I just give you some random number, and characteristic length 1 meter. So the Reynolds number is this much. So in the next video, we'll talk about how this application, or rather this script, was developed, and we'll talk more about functions. So we can start to talk about functions, while if loops in the next few videos. So basic math has been covered, so next thing we can talk about is functions. Alright, so thanks for watching, sitting through this crash course with me. I'll see you guys in the next video.